All right, section E. So we're moving on to now the second type of equation, right? The first one was the slope-intercept form. They have such lovely names for them because they are exactly what they are. Y equals slope and our y-intercept, right? That's one equation. And that's the one we've been dealing with pictures too, right? Our graphs. Where does it start on the y-axis and what is it going up by? What's our rate of change? Now, if you take, and they've got the whole formula down here, the next one is called the slope point form. So you can guess what they give you. They give you the slope and they'll give you a point. So I know y-intercept is a coordinate too. It's a point, but it's a very specific point, right? It's what it is at the y-axis. Whereas this one gives you a point that's maybe not at the y-axis, right? It's somewhere on that line. It's kind of like these last ones here where they gave you the slope and they gave you a random point that was on the line, all right? Now, the only way to do that was to find the y-intercept and write the answer. Today, I'm going to introduce another equation where you won't have to find your y-intercept. You can actually use the point and write the graph. Okay, so it comes from, this formula actually comes from cross-multiplying your slope formula. Okay, yes, so the slope formula looks like this. It's at the bottom of the page. You can look at it, but I'm going to write it over here. Right, your slope formula is this. And what they did was, instead of going y1 minus y2, they just leave it as x minus, x1. All right, so they just kind of do that. And then what they do is essentially cross multiply. And you can do that because you have one fraction equaling another fraction. So your slope essentially is that. So you get a y minus y1 equals m bracket x minus x1. There's the whole slope point formula. That's what it looks like. And the reason why they put the little y1s is this one here, right? This one here and this one here is what you're substituting into. This x and y stay just like they did in the y equals mx plus b. Y and x are part of the formula. Y and x are part of the formula. Okay? That's what makes it a line, right? So they give you that also right here. Okay? So that point is going to be your point x1, y1 will go in here, and they will also give you a slope. All right. So, first example. They've done it for you already. So this, they're asking you to go backwards. Okay? Could you identify, just before we move to that, I just want to look at this one right here for 2 seconds. Okay? So the point they have here, the point was -2, 5. So the formula, remember, is y minus y1 equals mx minus x1. So remember, with those subtractions right there, your signs are always going to be different than what they appear in the point themselves. Do you notice that x was -2? When you subtract a negative, it becomes positive. Subtracting a positive, it looks like it becomes negative right here. Right? So whatever is in your coordinate will always show as opposites in your equation. So if I look at this one here, y minus y1 equals mx minus x1, I can see that my equation, my slope is 1/3. It's right there. And my coordinate that they put in, here's my x, It was positive 4 because subtracting a negative, right? So it had to have been a negative 4 that was in there, that was put into it. And if it's y minus y1 has to be just a plain positive 2. So those is what we can get from the equation. From those points, then I can graph this thing, right? Easily. I can go down to the bottom. And again, always plot your point first because you got to have a starting point. So far, so good? Everybody okay with getting these two things? Yeah? Okay. All right. Negative 4, 2. Oh, yeah. Negative 4 and then up 2. There's my point. And then I use my slope, right? 1 over 3, rise of 1, run of 3. 1 up, 3 over. 1 up, 3 over. 1 up, 3 over. I could go 1 down, 3 over also, right? You do a few, gives you a nicer looking line. And there is my line. Okay. Now, because I have introduced a second equation, you need to be able to go back and forth between the equations. So this is one way of writing this line, right? This is one way. I'm going to write it down again here. Y minus 2 equals 1/3 x plus 4. This is one way of writing the line. That is your slope point form. But what is another way you can write a line? The y equals mx plus b form, which is slope-intercept form. So you need to be able to change it into that form. Okay? So the first thing that I always do when I have it in this form and I have a fraction here is to eliminate my fraction. All right? So if I'm changing from point form to slope-intercept form, which is y equals mx plus b, first thing I always do is eliminate my fractions. Or I guess my denominator of my fraction. If there happens to be a fraction. So eliminate that, there we go, denominator. Keeping in mind this whole thing is one thing, right? So when I multiply by 3 and cancel, you don't have to worry about the bracket. This has to get multiplied by 3. This also has to get multiplied by 3. Everything gets multiplied by the 3. So I get a 3y minus a 6 equaling a 1, x plus 4. So your second step is to distribute. In this case, it's a 1, so it doesn't really change anything. Distribute to eliminate brackets. So this is essentially what I was getting you to do up on the boards, right? 3y minus 6 is equal to 1x plus 4.
I have a question.
Yep.
Why didn't you multiply the 3 in the bracket?
Because this is all one term,
Okay.
right? This fraction gets multiplied to this in the first place.
Yeah. Oh,
Yeah, I could have distributed it in first, right? But then I'm working with two fractions then.
Right.
Yeah, it's all one term. Remember, adding, subtracting determines terms. And since this is being multiplied, it's all one thing. Okay, and then the third step is to move. So you have y equals mx plus b. Right? My x is in the right spot. It's on the right-hand side. I have a number over there. The only thing I need to move is this guy right here, right? 3y is equal to 1x plus 4. And I'm going to add the 6 to the other side. It needs to move. Move it over there. 3y is equal to 1x plus 10. And then what is always your last step? Divide by what's in front of your y. And then clean it up. 1/3 x plus 10 over 3. So in this case, using the slope point form is actually a nicer equation, nicer line to graph, right? Using the coordinate -4, 2, and then using your slope of 1/3 gave you a nicer line, because look at what the y-intercept is. It's 10/3. It's not a very nice thing to graph. So a lot of times they'll use this form if the y-intercept is not a nice graphable one, or if it's a fraction, right? So if you look back on those ones that we did over here, right, this one here would be a nightmare to graph. So that's easily why they gave us a coordinate instead. What else do I want? Another thing they want you to be able to do is, from here. A lot of times they want you to be able to identify the y-intercept and x-intercept. Right? Do I have one of them now? By putting into the slope-intercept form, what does that give me? Why would I want to put it in this form?
It gives you your slope.
Gives me my slope, but I had the slope already.
Oh, and your y.
Right. By putting in this form, it gives me my y-intercept, right? So I can automatically say, my y-intercept is that. Now, the question is, do any of these two forms give me the x-intercept, though? No. Right? Neither of them will give me the x-intercept. This one gives me slope and a random point on the line. This one, when I put it into this form, it gives me a slope and a y-intercept. But neither of them will give me an x-intercept. What is special about an x-intercept? Like, how do I write them?
Number.
It's a number and
0.
0, right? Means that y has to be 0.
Okay.
So let's go back to the equation again. It doesn't really matter which one you use, but if I went and put a 0 in for my y, I would be able to solve for an x and get that. All right? So you can do the first one, y minus 2 equals 1/3 x plus 4. Right? So if I use that form, my 0 is going to go in here. And really, it's just manipulating your equation. Gives me that. I'm now there. How do I get x by itself? What's always the first thing to do? Eliminate denominator of my fractions. If you want to get something by itself and you've got a fraction, get rid of it. And how do I get rid of it?
Multiply by 3.
All right. Multiply the numerator by it. But what I do to one thing, I must do to everything. But keep in mind that this was all one term anyway, so don't multiply these ones. Cancel, cancel. I get a -6 equaling, and then 1 is not going to change this, so x plus 4. And the last step, subtract off your 4. Look at that. There's my x-intercept. So this graph, this point here, is going to cross my x-axis at 0, -10.
The other form works too, by the way.
Right? Yes, it does. I'm going to show that one too. So yeah, if I had extended my graph down 1, 3 over, there it is. There's my x-intercept right there. Yep. Oh, yes, I have it backwards. Sorry. Yep, you're right. I'm going to move it up here then. -10, 0. There it is. -10, 0. And then my y-intercept is, 3 1/3. You can use the other equation too, right? y equals 1/3 x plus 10 over 3. 0 equals 1/3 x plus 10 over 3. How do I eliminate the 3 again?
Multiply.
Multiply that by 3. Multiply that. No, you can't cross multiply. The reason you can't do that is there's 2 fractions on the right-hand side. But 0 times 3 is 0. These 3's cancel out. Those 3's cancel out. I get an x plus 10. Subtract off the 10. -10.
Way easier. I like that one.
It's your choice. They both get the same answer, right?
I guess so.
Yep.
I mean, if you look at them,
Yep.
yeah.
All right. So as we're going along here, let's keep section D, which is your slope point form. All right. You need to be able to y minus y1 equals mx minus x1. You need to know your formula. All right. You need to be able to get m and your x from the formula. And graph it. All right. What else do you need to be able to do? You need to be able to change the form into the other form, y equals mx plus b. Okay, you need to be able to do that. And you need to be able to identify your x and y intercepts. Okay, so far that's all we've done and we've got there. We did all that in one question.
Wow.
So far so good? All right. Let's see what they ask us here. Now, this time they don't give us an equation, but they give us a graph. How is that any different?
It gives us lots of information.
It gives us some more information. It says, write an equation in slope point form for this line. Then write the equation in part A in your slope intercept form. What is the y-intercept of this line? Alrighty.
Roughly about...
So, when I see write an equation in slope point form of this line, what's the first thing I'm going to do? Write out the equation.
Pre-made version.
Okay, write out the equation. Because that's going to tell me what I need. Right? It tells me that I need a slope. And I need some kind of xy coordinate. Right? Yeah.
Let's do the one that's positive, not negative.
Okay. We do have a couple coordinates on here, right? You have the coordinate -1, -2. And you do have the 3, 1. And what Justin's saying is, let's use the 3, 1.
Not the negative.
If you put the negative in, you'll get a positive within the equation. Or you can put the 3, 1 in, and it's your choice. So I do have a couple selections there. What else am I missing?
Your
Slope. Right? And I'm going to go from there to there. So my slope is what? 3 over 4, positive or negative? Positive. Okay, so we'll go with the 3, 1. Okay. Now, if you chose the 1, negative 2, all right, when you have this equation, it all depends on what coordinate you pick is what it looks like, right? So if Justin picks the 3, 1 and Stacy picks the negative 1, negative 2, their equations are going to look the same, right? Or it's going to look different. And so they might go, oh, well, those are two different equations. They are the same equation. You just use different coordinates on the line. So that's why a lot of times they'll ask you to write the other form, which is y equals mx plus b. It makes no difference whether Justin uses the 3, 1 or Stacy uses the negative 2 or negative 1, negative 2. When you manipulate them down into the y equals mx plus b form, you will get identical equations. Okay? So whether you write it as y minus, what do I need, 1? Yes, this is my x and that's my y, equals 3/4 x minus 3, right? That's my slope point, right? If you write it with the other coordinate, which happens to be negative 1, negative 2, you'll get y plus 2 equals 3/4 x plus 1. See, they're totally different equations when they're in slope point form, but they will be identical if they're on the same line when they're in y equals mx plus b form. So we've figured out the pattern. What's the next thing to do? How do I get it into y equals mx plus b? Get rid of your fraction, distribute your bracket, move things, get y by itself. Okay? So we're going to times by 4. 4y minus 4 equals 3x minus 3. Okay?
Distribute.
Exactly. So I'm going to multiply by 4.
Let's do this. You use your side.
So I get a 4y minus 4 equals 3x minus 9. And I'm going to subtract off the 4. 4y is equal to 3x minus 9 plus the 4. 4y equals 3x minus 5. Look at that. See? Both equations. In the end, divide by the 4, divide by the 4, divide by the 4, divide by the 4, divide by the 4. Y is equal to 3/4 x, which we already knew the slope. There it is. And my y-intercept. So it didn't matter which coordinate I picked. In the end, one of the reasons why they ask you to get the other form is that so that you get the form that all the equations will turn into. So these ones are unique, depending on what coordinate point you pick, but your y equals mx plus b form is always the same. And it says write the equation in this form and identify the y-intercept. Y-intercept, right, 0, negative 5/4. Which you can easily say is negative 1 1/4. There it is. Negative 1 1/4. Spiffy, spiffy. Should we just practice getting our x-intercept? Let's practice our x-intercept. Because again, neither of these two equations will give us x-intercept. So what do you want to pick? Does it matter? Nope. I'm going to go with this guy over here. Because I don't know, he looks pretty. I'm going to choose any equation. You can, I forgot how to spell that for a second. Choose any equation. Doesn't make a difference. You will get it. Put y equal to 0 in. Y plus 2 equals 3/4. I'm choosing this one. Makes no difference which one you choose. 0 plus 2 equals 3/4. That guy's gone. I get an 8 equals 3. Oh, I did choose the longer one out of the two, didn't I? That's okay. And I get 7/3 equaling x. So did I miss it? Oh, yes, I did. There we go. I forgot to distribute properly. Good job. Let me fix that.
No.
And 3x through 3, that means I'm going to subtract 3. I get a 5 instead of a 7. Doesn't end up giving me anything that's prettier. But at least it gives me the right answer now. And 3 into 5 goes 1 2/3. So it should be approximately 1 2/3. And if I had checked, even when I did that mistake, if I checked my line, which 7/3 would be 2 1/3, I can see that 2 1/3 would have been wrong, because 2 1/3 would have been here. And 1 2/3 is exactly what I needed. So I could have checked, right? Check to make sure that it actually works. And I would have noticed then that I had a mistake. All right. The second half of it, I think I'm going to leave for today, is using a problem to writing equations and then throwing in some parallel and perpendicular. So I'm going to give you the questions that you're going to start on, and then I'll leave the other examples for tomorrow. Okay? So if you turn to page 47, question number 4 and 5 you can easily do. This one, they give you the equation. They ask you to find the slope and the coordinate of a point. Remember, your point is always opposite of what it appears in the question, right? Then they ask you to go the other direction and just write them in the slope point form. You don't have to change it into the other, oh, this is an M. You don't have to change it into that form. I will tell you which ones you have to do that. So this one is just put it in that form. Okay? Second page, you're just graphing these little babies. Okay? For each equation, write an equation in slope point form. And write an equation in, oh, yes. So this page here, number 9, they're asking you to first write it in this form here. Then they ask you to change it to this form. And then they want the x and y intercepts. I may not have given you enough room for this. I had to write very small to get mine all in. Like very small. Okay? So they're asking you to do absolutely everything. This is like example 1 and 2, where we did all the steps. I wrote it in that equation, I changed it in that form, found my y-intercept, and then I found my x-intercept. That's what they're asking you to do in question number 9. Okay?
Fun.
And and do 12. Leave 10 for the moment. So that should be enough to get done today. 6, 7, 1, 4, 5, 6, 7, 9, and 12.
Why did you go 10, 12,
I rearranged them. Oh, and you can probably do 14. It's just matching the graph too. That leaves just our word problems and the ones that I want to deal with tomorrow. Okay?
Get the sign out though.
So you're doing 4, 5, 6, 7, 9, 12, and 14. Okay, I know some of the questions are out of order. I just put them that way so that you had more space to work on them. All right, that is done.